Let's look at exponential functions. We'll observe the table of values and notice the similarities and differences. It's important to note now that this y equals x squared, as we've seen in previous lessons and activities, is an example of a quadratic function. But this is not a quadratic function. This is the exponential function, where our unknown is the exponent. Notice that both of these functions only have positive values. So the y values are all positive. The values of the exponential function increase as the x values increase. So here's the smallest value, and as it gets larger, from -5 to 5, so too does y. Y gets much bigger. The values of the quadratic function first decrease and start increasing after the origin in a symmetrical pattern. So it decreases from 25 down to 0 and then climbs back up again. As the x values become smaller and smaller, the value of the exponential function becomes a very small positive number. So notice, these continue to get cut in half, from 1 to 0.5. Half of 0.5 is 0.25. Half of 0.25 is 0.125. So this is going to continue getting smaller and smaller, but it will not reach 0. For an exponential function, y value will never be 0 because 2 to the x will always be a positive number. Observe the graphs of the two functions and notice the similarities and differences. Here's y equals 2x and y equals x squared. There's an axis of symmetry located here. X is equal to 0. The axis of symmetry for y equals 2 to the exponent x does not exist. There's no line that can be drawn that will create a mirror image. The vertex, the quadratic function has a vertex. It's at 0, 0. For the exponential function, there's no vertex. Maximum and minimum values. There's a minimum value for this quadratic function. The minimum value is 0. The maximum or minimum value for an exponential equation does not exist. There's no maximum because this line will continue on to infinity. And there's no minimum value because it will continue to get closer and closer to 0, but will never reach there. For the parabola, y equals x squared, it rises ever more steeply as x becomes more and more negative. So as x becomes more and more negative, it becomes steeper and steeper and steeper. The exponential function, y equals 2 to the x, seems to approach the x-axis ever more closely as x decreases more and more. So as x decreases, y gets smaller and smaller. On the left, you'll see a zoomed in graph. The blue line is the exponential function, and the red line is the quadratic function. On the right, you see a zoomed out version. Let's notice a few things. For the exponential, you can notice that there is one y-intercept. The same can be said for the quadratic. There's only one y-intercept. You can also see that the exponential and the quadratic function meet at 2 points. here, and here. Some similarities are that on the positive side of the x-axis, the y value will approach infinity for both the quadratic and the exponential. These blue and red lines on this side will continue on forever. Notice for the exponential function that the line never meets the x-axis. It will approach it, but it will never get there. Notice that the axis of symmetry is present for the quadratic function, the red line. It's located on the y-axis. But there's no axis of symmetry for the exponential equation. There is no mirror image. There's no point where we could cut through the exponential line or function and have a mirror image. We're going to look at the first and second differences for the two functions, y equals x squared, the quadratic function, and y equals 2 to the exponent x, the exponential function. Here's our table of values for y equals x squared. Our x's range from -5 to 5, and they go up by steps of 1. Making sure that that stays a constant is important. Here are our y values. Now we'll calculate the first differences. So the difference between consecutive y values. So between 16 and 25, 16 minus 25 is -9. Our next one, 9 minus 16, is -7. Between 4 and 9, it's -5. Then 1 minus 4 is -3. 0 minus 1 is -1. 1 minus 0 is 1. 4 minus 1 is 3. 9 minus 4 is 5. 16 minus 9 is 7. And 25 minus 16 is 9. Notice our first differences go from -9, slowly getting bigger, up to +9. Also notice that the first differences are not constant. If they were constant, this would be a linear function. But we know it's not. This is a quadratic function. So let's now look at the second differences. -7 minus -9 is 2. -5 minus -7 is 2. -3 minus -5 is 2. -1 minus -3 is 2. And what we're going to see here is that the second differences are a constant 2. Let's now look at the first and second differences of the exponential function y equals 2x. Here are our x values and our y values. We'll now calculate our first differences. So 0.0625 minus 0.03125 is equal to 0.03125. Notice that these two numbers are the same. That's because this divided by 2 is equal to this number. Let's look at the next one. 0.125 minus 0.0625 is 0.0625. We're seeing a pattern develop here. The next one, 0.25 minus 0.125 is 0.125. So what we're seeing here is that this is increasing by a factor of 2 each time. So 0.25 times 2 is 0.5. So the difference will always be the previous y value, 0.25. Here, 0.5, because 1 minus 0.5 is 0.5. 2 minus 1 is 1. 4 minus 2 is 2. 8 minus 4 is 4. 16 minus 8 is 8. And 32 minus 16 is 16. Notice that these are slowly growing by a factor of 2. Let's now look at the second differences. So what is the difference between 0.0625 and 0.03125? It's 0.03125. And we'll see the same pattern replicated here in the second differences. If we look at the bottom and go all the way to the top, we're dividing by 2 each time. This means that unlike the quadratic function, the exponential function does not have a constant second difference. Looking here, the quadratic function has a constant second difference of 2. But in the exponential function, the second differences are not constant, but rather the ratio is constant. So each one of these is half of the previous. So 16, half of it is 8. Half of 8 is 4. Half of 8 is 2. So the ratios between the first differences are constant. The constant ratio can also be seen in the y values. We don't need to look at the first and second differences. The y values also have a constant ratio. Notice that as you increase your x value, your y will double each time. That's a constant ratio.